All right, so it's Sunday night, late day today. Been working a lot on the Nixie relay clock. Ran into an issue. Been debugging for the last 2 hours and finally figured out stupid software stuff. And then I got my steak, the salt's on the steak, so I need to let it sit there for at least an hour before it cooks. So I'm doing a video. So I got, despite my reservations about software, I did software today. And so what we have here is the Arduino. There's the RTC and its battery, and then this is the GPS. And then I have an LCD display just to help me know what's going on. And I have the minutes and the seconds counter. So what I worked on was getting the Arduino to read from the GPS and the RTC. And so what's shown here on the display is on the top, it's what the time is according to the RTC. And yesterday I set the time in that, and on subsequent power cycles, it retains that. And what's shown, and that's in UTC, Universal Coordinated Time. That's why it's 1 in the morning tomorrow already. And then shown below is what I'm reading from the GPS. So that's the actual time. It's not updating, but that's the actual time. And I have a conversion, minus 7 hours to convert it to Pacific Daylight Time. And so I worked on just getting the libraries going to have the data flow going back and forth, and on the time zone conversion. What's also shown here is the 1 there means that it has a fix. 6 is how many satellites it sees. And so inside, by the window, it sees 6 satellites. I have an antenna when it's in a real system that I'll SMA. I have an SMA cable that'll go out to the back panel, and then you can have a button antenna or a long antenna if you want to do a GPS sync. The RTC, it's a 50 ppm clock, I think. So that means that every 20,000 seconds, it might lose a second, which means it could lose up to 4 seconds a day. So you don't want to rely on just the RTC. The green light flashing is the PPS, and so that's coming from the GPS. So that PPS, that's atomic clock PPS. So when I clock the real system on that, it'll be very, very accurate when I'm on the PPS. And then occasionally you'll see it blink red. There's a red LED, and that means that it's getting right there. It's getting a update from the satellites. And so there's constantly information flowing over to the Arduino about the date, time, longitude, latitude, altitude, what have you. And I have a button here that when you press that button, it actually reads the Arduino, or reads GPS and the real-time clock. It updates the display. And the real test was I have the seconds counter hooked up, and it resets the seconds counter, and then the Arduino sets the seconds. And so, it's on 56 now. When I hit the button last time, it was 56. So if I hit the button again, it goes to 52. And it counts up to 52 just like you would want it to. And I have 8 satellites in view now. And the real-time clock is running a second behind the GPS. So that's the drift that you would, sort of expect. And you can also see that, it's 1:25 a.m. on September 20th. And here, in California, it's 6:25 on the 19th. So if I hit it again, so it should come to 27, it's 27. If I hit it again, it's 30. And I can change how fast it counts, in the software. But this is just a test to make sure. I mean, the hardest part is interfacing all these things so that, in real life, I'll have a sync button down here. When you hit the sync button, that's basically what this is. It's syncing. And then I know what the date is. And so there'll be a button, and then since it's I can set 51 on here because it's 51. I'll be able to set 9 2021 on the real system when he hit the date button. And so I'm sort of, the big software challenge is finished with. The other complication is there'll be a switch to select between UTC or local time, and that's why I, did the conversion here to display it both ways to make sure I can do it. And just to see, I mean, I'm part of the software thing is I'm not used to the semantics and the syntax about the coding, so I was able to work through a lot of those issues. So, for instance, here is where I look at, if it's if it's 2 a.m. and we're -7 because it's the West Coast, you actually have to roll back a day. And if you roll back a day and it's the first, you actually have to roll back a month. And if it's January and you roll back a month, you have to roll back the year. And so this is part of the logic for that. So, for instance, if the month is 4, so if it's April, the new month, if you're rolling back, is going to be March 31st, and the year is the same. And so I had to do these. If it's May and it's the first, it turns into April 30th. The tricky part is February. So if it's March 1st and you roll back a day, it turns into February 28th, unless it's a leap year. So if it's a leap year, then it turns into the 29th. And so I think that I have all cases covered. 2000 wasn't a leap year. 2400 isn't a leap year. Actually, 2000 was was a leap year. Every 400, it isn't a leap year. Anyway, so I'm good, for the next 100 years with this algorithm. So I'm sort of happy with the software work. I worked through it. The big problem I had was when I was doing this, it wouldn't reset. It would be able to increment, but the reset wouldn't work. And I thought it was an electrical problem, so I was debugging things. I swapped the Arduinos. I even put in a circuit that had, a buffer to try to, the reset circuit has 3 transistors versus 1 for just the clock, because the clock thing was able to reset it, but the reset just wasn't working. I moved pins around. I did everything. I just couldn't figure it out. And it turns out that I, in the code, hadn't defined the those pins as actual outputs. And so the fact that it drove weakly, that was just, an accident. And once I changed it to, that pin's an output, then I had sufficient drive to switch the relays. But I was pulling my hair out for a couple hours on that. And then when I figured it out, I was like, duh, software is why I hate it. So it all works. Again, it doesn't look like much, but, I'm going to hook up, all these lines into the Arduino, and then I'll be able to do what it needs to do. So I have most of the code written, or modules at least. I'd probably get a C minus in a comp sci class for my coding technique, but it works. And then also you can see on this board, this section is in logic or the power domain of the relay board. This top section, it's actually going to be a 5-volt domain. So I have, this is 5.7 coming out. So this is higher voltage than the Arduino would like, and I give 5.7 to the regulator that's on the Arduino, and it's even though it's an LDO, I get 4.8 is what is sort of in this section of the breadboard. So it makes the LCD happy and the GPS and the RTC happy. All this stuff is 3.3 volt compatible, and then when I drive these signals, I'm driving transistors, and so there's not a lot of current that flows through there. So I'm actually, just testing out the 2 voltage domains. In an effort to figure out what was wrong, I actually hooked everything up to the 5.7 out of here, and I think I blew out one of my LCD displays. And so, don't do that. It exceeds the absolute maximum rating for that part. So the next step is to I have the pinout defined for all the pins that are coming from the interface into the processor section from the board section. And so I'm going to work on sort of wiring up, assigning pins to the Arduino. The one thing I'm still waiting for is to set the time zone. I don't have enough pins on the Arduino, and so things like 12, 24, or hour mode, what time zone you're in, the offset number. Those are things I'm going to have attached to a I2C I/O expander, because I'm already using I2C pins, and I'll have thumb wheels in the back where you can set the offset. And so on boot up, it'll figure out what time zone you're in, and if you want to be in 12, 24 hour mode, and that saves a lot of the pins for the other functions. And so I need to do pinouts and then actually work on the real code. But again, being able to press the button 7 works just like you want it to. So I'm really happy. And the software's fun. Once you sleep on it and you think about it, you just break it down and it works. So the next step will be to work on the actual software, wire up all the controls into the Arduino, and this is the interface here, and I'll have another interface here, and just ribbon cable it over, because I unhook this section and take it over to the PC to do the testing. So hopefully next week I'll have a lot more progress. All right, thanks for watching. Have a good week. Bye.